Okay, we are live. Hi, this is William Ramsey. Welcome to William Ramsey Investigates. On today's show, I have a very special guest, a returning guest. We just talked in April 2025 about his excellent book. People check it out. The full title of the book is The Whys of Heart, a modern day reimagining of the Scopes monkey trial. It has really good reviews on Amazon right now, 4.9, 25-star reviews, and it's well deserved, timely. Check it out. I will put a link to the show we did. But we were talking offline after we finished the last show, and he has other interests. Things I can't say I'm a science person or physics, but I've done some interest. People have talked about Einstein, some questionable ideas about how valid he is. But anyway, we're going to talk about this. And his name is Hans G. Schantz. Last name spelled Schantz. If you're watching this on Rockfin, Rumble, or X, you'll see that he works for and with the Society for Post-Quantum Research. And his website is thespqr.com and also aetherzar.substack.com. So I'll put those links in the show notes. But he has a bunch of slides. And like I said, I'm not really, I think this is optimal in a way because I don't know that much about kind of modern physics, but he can talk more about that. So Hans Schantz, welcome back to the show.
Well, thank you so much for having me on again.
Excellent. So for people who didn't hear our earlier show, maybe you can talk about your recent work. I know you're posting a lot on Substack, and maybe just talk about your background and interest in this particular subject, relativity, Einstein, and modern physics.
Sure. Yeah, I started off in school studying industrial engineering because I had read Atlas Shrugged and really liked the idea of being a creator and an entrepreneur. And I got most of the way through my industrial engineering training, and just great training, good general engineering background, and how to run a business, production control, project management, things like that. But as I got near the end of that, I realized no one was going to hand me a copper mine or a steel mill or a transcontinental railroad. And if I wanted to run a business, I was going to have to invent something or come up with some concept that I could wrap a business around. That got me into physics. I finished a second undergrad bachelor's degree in physics and liked it so much I went all the way through grad school, getting a PhD in theoretical electromagnetism. Well, then I had the unwelcome discovery that what physicists regard as electromagnetism is a bit different than the practical everyday electromagnetism that electrical engineers put to practical use. So I had to do a bit more training and get myself up to speed before I landed a job doing ultra wideband antenna design. It was a great job. I learned a lot, was able to synthesize a lot of my theoretical physics ideas with some practical applications and learn not just about how antennas work, but how electromagnetism works and develop some ideas for how that all plays out. I left the ultra wideband business to do a startup at last. With some friends, I co-founded Qtrack Corporation. I invented a way to do indoor location using low-frequency near-field signals. The conventional way uses high-frequency signals. They tend to bounce around. It makes it really hard to tell where whatever it is you're tracking is. We used signals down in the AM broadcast band, very long wavelength, very low frequency, and built a product that was able to track people to an accuracy of about 50 centimeters, a couple feet or so. It was used in about a third of U.S. nuclear plants, a bunch of industrial customers. It gave me an opportunity to master another realm of electromagnetism, the whole area of near-field electromagnetism and how these short-range, long-wavelength, low-frequency links work. Well, that was kind of a hand-to-mouth existence, never terribly successful. We ultimately had to sell out, and I've been working in the defense industry since then. But it gave me an opportunity to write a book about ultra-wideband antennas, the art and science of ultra-wideband antennas. If you're interested in time-domain electromagnetism, you might want to look that title up. And it helped me appreciate that physicists really don't understand very well how electromagnetism really works. And I can go into the details later, but that led me on a quest to try to understand where physics went wrong, how we got the premises that we have on how things work, why things like pilot wave, quantum mechanics have been largely ignored in favor of less reasonable interpretations, not only of relativity but of quantum mechanics. And that led me to a historical study to try to track that down. And the central figure involved in that process is Einstein. And I think I've come up with exactly what went wrong and how Einstein led physics the wrong way and tried to save it at the end, but his dream has not yet been realized. So that is what I will be discussing in the presentation today.
Great. And that I've heard that from other people, that the theory of relativity isn't, there's holes in it. I mean, I've heard this before. Would you agree with that? Is that kind of your position, that there's things that Einstein left out or didn't address in physics?
The fundamental issue, and I'll be getting into it in the presentation, is it's really a backwards way of looking at things. What he did was take a look at the emerging discoveries in electromagnetism, trying to understand things like the Michelson-Morley experiment that seemed to indicate there wasn't any ether drift. And he decided to do a top-down approach of deducing the physics, the Lorentz transforms, which had already been discovered, deducing them from two simple principles. It was a remarkably creative and clever thing to do, but in inverting the hierarchy and making it a top-down theory like that, he believed that no mechanism was necessary and that it was a complete waste of time to talk about that we should focus only on the observables. And that's been an idea that has plagued physics ever since.
Gotcha. And that's the whole kind of concept of the aether, right? Is that there's some kind of other unseen force affecting physics. Is that too simplistic?
The idea of the ether came up as the wave theory of light was developed initially by principally by Fresnel in France. And then as James Clerk Maxwell discovered the laws of electromagnetism, he was able to merge optics and electromagnetism and demonstrate that light was an electromagnetic phenomenon. And if you have a wave, the natural question to ask is, in what medium is it waving? And the answer to that was this mysterious medium called the ether that somehow was able to support all of these waves at insanely high frequencies, at insanely fast velocities, and yet was so immaterial that planets would go through it without being slowed down in the least, and that it was very hard to detect. And that's the paradox that people were wrestling with when Einstein came around and said, let's not worry about how electromagnetism works. Let's just deduce how electromagnetism works for moving bodies from these two simple principles.
Gotcha. So those are kind of the themes, the kind of logical themes that are going to be in this presentation, is the difference between induction and deduction. Is that right?
That's one of the fundamental themes of my book.
Gotcha.
And it really goes all the way back to Plato and Aristotle and their approaches. I'll talk about that more when we get into it.
Okay. I just am trying to define terms before you get into your presentation. Sometimes that makes it clear what we're talking about. So I'm not that familiar with this stuff either. So, but yeah, so this is the way that Einstein looked at his theory of relativity, right? Is these different, he just made these assumptions from the top down about it. He induced it, right? Not deduced it.
Well, he deduced it from
not induced
the fundamental principles.
Gotcha.
So, I mean, deduction is the idea where you start with some fundamental truths, some axioms, some basic principles, and work out logically what their consequences are. Induction is when you take a look at a bunch of specific instances or examples and try to infer from them what general law or principle connects or governs them.
Gotcha. Okay. Okay, so induction, deduction, and Einstein. And Einstein's ideas did not come about in a vacuum, right? Like there were other people doing similar physics around that time. Is that correct?
That's a very interesting question. Maybe I should get into that in
Right.
the.
Well, you can do the slides. Yeah, if you would like to start with the slides, that's fine too.
Yeah, let me go ahead. We're
Okay,
covering a bunch of topics that I'm going to be hitting.
Okay, sorry.
Anyway, and if you have any questions or if anything's unclear, it'll probably, those may be questions the audience is having too. So please feel free to stop me. And
Yeah, we already have one question, so we can address that whenever you're ready. But let's get into the slides.
Why don't we go ahead and take that question?
Would you like to see it? Sure. This is Johnny. He writes, can the speaker opine on whether Alexanderson alternator transmitters antennae may be an under-examined phenomena re quantum spooky at a distance longitudinal scalar waves?
Oh, those are all some very interesting questions. The Alexanderson alternator was one of the first high-frequency radio transmitters. It was basically a mechanical oscillator that would whip around fast enough to generate radio waves, now relatively low-frequency radio waves of tens to maybe 100 kilohertz or a little more than that. And because the wavelengths were so long, a lot of the RF involved, particularly in and near the antenna, would involve near field phenomena that are not, at least at the time, were not very well understood. Now, I know I'm trying to remember the gentleman's name. I think it may be Eric Dollard, who has done some investigation, has some interesting results and claims there that I haven't really dug into. I do think the process of radiation is an under-examined phenomena, and I should probably come back maybe in a few months when I have a presentation ready to talk about my understanding of electromagnetism and how it works, so we can get into this a little more deeply. But yes, these are definitely under-examined phenomenon. We'll see a little bit about Einstein and the spooky action at a distance in the talk. And longitudinal and scalar waves, an interesting topic. I'm trying to do a paper on that in the next few months. I think a lot of it is overhyped. There are longitudinal waves in electromagnetism, but those waves aren't really important by the time you get more than a wavelength or two from a small transmitter. Now, there's this scalar wave theory that supposes there are undiscovered terms or ignored terms in the laws of electromagnetism that allow supposed scalar waves to generate from 0-point energy, create effects at a distance. But I have yet to see a coherent account of how they're made and how they're detected and what their link law is that has convinced me there's much behind that notion. But I'll be looking into that hopefully soon. It's on my to-do list to look into that further.
Great, excellent.
Okay,
let's do it. Let's go into the slides. Great.
Well, what I'll do is I'll begin with kind of the conventional perspective that you'd probably get in a physics class about relativity and about Einstein. Then I'll talk about some of the less appreciated aspects of Einstein's career and the relativity history and development. I'll talk about his personal life. I'll talk about how the eclipse of 1919 was a major event in promoting Einstein and bringing his theory to prominence, about the aesthetics of relativity and the critics of relativity. It's fascinating looking at how the publicity behind Einstein and relativity rolled out. And I'll take a closer look at Einstein's trip to America in 1921. I'll talk about some of the very contentious arguments between advocates of what was called Deutsche Physik, German physics versus Jewish physics. And finally, I'll talk about some of the lessons here for the foundational narratives that govern physics. And I'm really happy to be able to present this to you and to your audience because there are a number of really intriguing suggestions about how Einstein and the campaign to promote him may have had ties to more occult or esoteric groups. And I want to lay out some of the clues I haven't been able to track down, and hope that maybe someone in the audience will have some insights and will get back to me and clear this up. So let me begin by talking about relativity. In 1887, two researchers, Michelson and Morley, set up an interferometer to basically bounce light back and forth on a path on paths at right angles to each other. And they assumed that they would see light slowing down depending on which way the interferometer was changed or was oriented. And what they discovered was a null result, that the change in the speed of light on the two different directions was much less than they were expecting. Now, it wasn't a zero result, but it was a lot smaller. Now, Heaviside, a couple years later, predicted that a moving electrified sphere would contract along its axis of motion, just inferring that from the laws of electromagnetism. A researcher named Fitzgerald came up with the idea that the interferometer itself might be contracting as it moves through the ether. Larmor, British physicist, did a lot of work on radiation and other subjects. He predicted the concept of time dilation and started developing transforms to discuss how electromagnetism changes with moving bodies. Lorentz described them in coordinate transformations. And in 1904, a French scientist, Henri Poincaré, developed the term, the principle of relativity, and he predicted that we would have to have a new mechanics where where velocity is strictly limited to the speed of light. So that is the context in which an obscure, no one had ever heard of him, patent clerk in Bern, Switzerland, named Albert Einstein, wrote a paper in 1905 suggesting that we could explain all of these phenomena, the Lorentz transformations, from just two principles. First, that the laws of physics are identical to all observers in non-accelerating inertial frames. And second, that the speed of light is the same for all observers, independent of the relative motion of the various light sources. And from those principles, he showed that you could derive the Lorentz transforms and the relativistic mechanics that Poincaré had begun exploring. Well, this gets us to the discussion we were having before we got started on induction versus deduction. And I like to think of it in terms of a Platonic versus an Aristotelian approach to science. And that's a little controversial because people will use Plato and Aristotle as archetypes with different shades of meaning. So I want to be clear what I mean when I talk about Aristotelian physics. A lot of people will look at it in terms of the medieval schoolmen with their logical syllogisms, and that's not the sense in which I'm talking about something that's Aristotelian. By Aristotelian, I mean using induction in order to come up with basic principles, whereas a Platonic approach, you're using fundamental axioms or principles in order to work out predictions that you can then, say, validate in an experiment. A good way to look at that is to see how Aristotle and Plato used their approaches in practice. Like if you take a look at their analyses of politics, Plato started from ideals of human justice and behavior and human character, and deduced how the philosopher king should rule the society. Aristotle, on the other hand, gathered the constitutions of over 100 different governments and broke down and started analyzing what worked and what didn't. And that's a good example of Plato's deductive approach versus Aristotle's inductive approach. But it really is a cycle, and you need a balance of induction, looking at new phenomena and coming up with new principles, and to complement that, taking those principles, working out consequences of them and then testing them. And I would argue that today physics has gone way on the Platonic side, where we've taken a lot of these principles, including the principles that Einstein identified, and are taking them as axiomatic and not doing the inductive investigation necessary to try to develop new principles or possibly question the principles that we have. So that's a theme of my work on my Fields and Energy Substack.
Gotcha.
Now, about a decade later, Einstein extended his special theory of relativity to come up with a general theory of relativity. That's the idea that mass and energy cause space to curve, and that gravity is just a reflection of bodies moving on this new curved space-time geometry. I won't bother going into the tensor math because it gets kind of complicated, but I think the best shorthand explanation of it was coined by John Wheeler, who said, space-time tells matter how to move, and matter tells space-time how to curve. And that basically explains the fundamental concept behind general relativity. There are a bunch of interesting details about that gamma, or the lambda you see, the cosmological constant, and expanding universe and cosmology, that I'm going to have to skip for now. But when Einstein came up with that theory, the question arose how to test it. He was able to show that his theory would match the observed perihelion advance that had been observed in the planet Mercury. And it predicted that the sun would bend light. So, people were going out to eclipses and trying to take pictures of the sun during an eclipse and see if the star field behind the sun was distorted. It's a very tricky thing to do because you don't have a lot of time to take the picture, and you got to get it right the first time. And you're packing up all your equipment and going to the jungles of Brazil, or one group went to, in fact, a German expedition went to Crimea in 1914, and World War I broke out before they were able to take their data. So there are all kinds of hazards that experimenters ran into trying to test this and take some measurements and see if they could validate it. So ultimately in 1919 it was confirmed. So if you look at Einstein's career, he started off as a patent clerk in 1905 with 4 great papers: the special relativity paper. He did a paper on the photoelectric effect, on the energy mass equivalency equals mc squared, and on the atomic theory. In 1915, he came up with general relativity. In 1919, that was confirmed by Dyson and by Eddington. Looks like some of my newspaper clippings got over the text, but in 1921 he had a triumphant U.S. tour and ended up winning the Nobel Prize in 1922. He came up with Einstein-Bose statistics to govern the statistics of bodies under quantum mechanics. In 1927 was really one of the pivotal moments in physics history at the 5th Solvay Conference, where Einstein maintained that God does not play dice with the universe. And Bohr's answer allegedly was that Einstein should stop telling God what to do. Bohr ultimately triumphed in the physics community with his Copenhagen interpretation. In 1933, when Hitler came to power, Einstein fled Germany. In 1935, from Princeton, where Einstein had ended up, he wrote a fascinating paper that ended up being, I think it's his most cited paper today, and it's one of the ones that today still has some of the greatest interest. It's called the EPR paper, after the initials of the authors, Einstein, Podolsky, and Rosen. And Einstein argued that quantum mechanics was not complete. Basically, he argued that there would have to be hidden variables to account for certain behavior in quantum mechanics to avoid the concept of spooky action at a distance. In 1939, he collaborated with a friend of his, Leo Szilard, to write a letter to President Roosevelt suggesting that the U.S. should start an atomic bomb research project, which did happen, of course, led to the Manhattan Project. And in 1955, he ended up dying in Princeton. So that is the conventional biography that you would get if you asked your physics teacher to explain Einstein's career. And what I want to do now is go a little further in depth into his personal career and some of the personal background.
Okay.
And Einstein credited an Austrian physicist named Ernst Mach with inspiring a lot of the ideas behind relativity. He said that it was Mach who, in his History of Mechanics, shook his dogmatic faith in classical mechanics, and that the book exercised a profound influence upon him. Mach had what came to be known as a positivist approach to science. He argued that the world isn't composed of things, but of sensations, that it's our observations that matter. He argued that atoms aren't things, they are a mental model for classifying our observations, that we can't ascribe any reality to them. He argued that it really doesn't matter, it doesn't make any sense to talk about whether the Ptolemaic versus the Copernican model of the solar system, that one is right versus the other. They're both just ways to organize the data of our observations we make of the planets, and that it doesn't make sense to talk about one being real versus the other. And that idea developed into logical positivism, and it was a great influence not only on Einstein, but on the physics community in general. The quote by James Jeans is really kind of telling, where he argues that physics has driven us to the positivist conception that we cannot understand what events are, but can only describe them in terms of mathematical terms organizing our observations. And that, as we dig into it, is really a reversal of cause and effect. It was more Mach and Einstein having adopted those principles which drove the interpretation of physics, and not the discoveries in physics which drove the adaptation of those principles. But we'll see that as we get a little deeper into what's going on here. Now, what's really interesting is if you go back and read Einstein's paper, and Max Born, his friend and fellow physicist, pointed out that many people will have looked up Einstein's paper, and when you read it, you will notice that it doesn't have a single reference to the prior literature. It's like it just appeared out of nothing from Einstein's imaginative, creative intelligence. And of course, Born pointed out that that is not true. A real interesting, fascinating sidelight, Einstein skipped his math classes and got a friend to take notes, and that was pretty much the only way he was able to pass his undergraduate math classes. His professor was Hermann Minkowski, who ended up developing the space-time geometry that we now use and is sometimes confused as being something Einstein did. Minkowski said, that Einstein always cutting lectures, I really would not have believed him capable of it, of developing relativity. And he also said, for me, Einstein's success came as a tremendous surprise, for in his student days, Einstein had been a lazy dog, never bothered about mathematics at all. So there's been some question about whether his wife may have been involved in assisting him. And it's really hard to sort that out. I don't have a firm opinion on it. There's a lot of people who've argued that one way or the other. But what has become known as their letters have become public in recent years is in 1902, Mileva, who was then his girlfriend and fellow student, gave birth to their daughter, Lieserl, and no one really knows what her fate is. It's not recorded in any of the letters. We don't know if she died in infancy of scarlet fever. That's one hypothesis. Some people argue that she was adopted. We don't really know for sure, but apparently, Einstein had a daughter with his girlfriend Mileva before they got married. They were married in 1903. In 1904, their first son, Hans Albert, was born. In 1910, their second son, Edward, was born. And in 1912, Einstein began an affair with his first cousin, Elsa. He ended up moving to Berlin in 1914. He stayed in Berlin. Mileva had enough at that point. He had been very dictatorial and abusive. There are letters that he wrote to her with his demands of how she should run the household if she wanted to remain in it. So she ended up going to Zurich with the boys, leaving Einstein there. Finally, in 1919, Einstein divorced Mileva and married Elsa. One interesting highlight that really stuck with me is it's important to understand Edward developed schizophrenia and had to be institutionalized when he was in his early 20s. And in 1939, Einstein was busy helping Jews escape from Germany. Mileva wrote him. Now, she would have been safe. She was a Serbian Orthodox Christian. Even if Switzerland had fallen to the Nazis like neighboring Austria did, she'd have probably been okay. But her half-Jewish son, Edward, who was in the mental institution, he would never have made it to a concentration camp. The Nazi policy was they just shot mental patients out of hand for eugenic reasons. So she asked Albert to help get Edward out of Switzerland and get him safe to America. And he didn't do anything. He refused to help. So, his personal life was pretty questionable, but there's been a mythos built up around Einstein as being, the ultimate wise sage and a benevolent figure. The Hebrew University of Jerusalem has earned an estimated $250 million licensing his image, everything from little Einstein's toys to all kinds of promotional uses of the Einstein name. Recently, a physicist argued that the relationship between Einstein and the press is a case in which a scientist's fame triumphed over the substance of his work. And I think that as we develop the story a little further, you'll see how that turns out.
I think that's true, but like his image is everywhere, sticking his tongue out, riding a bike. People quote him as kind of like a moral philosopher too. Personal life, not really batting 100% or whatever, so to speak. But yeah, it is interesting how what a cultural impact he has, more so than any of this information, the eclipse of 1919.
Oh, absolutely. And in fact, that's one of the things that I want to explore, where I've reached some dead ends on the publicity campaign and how Einstein got promoted, because I suspect there may have been other people involved in pushing Einstein for their own reasons. I mean, some of that's in the open, some of it isn't, and we can only speculate and look at some of the clues.
But he wouldn't be the first cultural figure promoted by other people. I mean, this is a common phenomenon, certainly in the United States or the West. Yeah, sorry.
And you can see where there was people had a lot of motives to do so.
Right. Gotcha.
Well, I want to go to the eclipse of 1919. I mentioned that a bit, how previous attempts had failed. But then two teams from England, one went to Brazil, and one went to an island off the coast of Africa. And they, through some pretty questionable means that a lot of people have commented look very suspicious, selectively threw out some of the results, and the results that were left confirmed Einstein's theory. And they went full speed ahead, saying that with complete confidence, the theory had been confirmed. Now, a lot of people spend a lot of time arguing that. I think it's kind of a waste of time to argue about the possible chicanery involved in the 1919 results, because it was definitively confirmed in subsequent eclipses in 1922 and 1929. So if there was some kind of selective editing or selection of the data, it doesn't affect the overall result. So his biographer, Abraham Pace, said that, November 6, 1919, that was the day the results were announced. He called it the day on which Einstein was canonized, which I think is an apt description.
Religious term. Yeah, right.
Oh, yeah. He's one of the saints of the modern day, religion of scientism. And the New York Times had the headline you see there about lights all askew in the heavens. This started the myth of only 12 men alive could understand relativity, and scientists were agog at the results. The Times of London also promoted this, revolution in science, new theory of the universe, Newtonian ideas overthrown. And there was this kind of famous photograph of a rather brooding Einstein on top of the cover of the Berliner Illustriert. I don't even try the German pronunciation there. A major German magazine. And you can't really read the German below Einstein, but it reads, a new greatest in world history, Albert Einstein, whose research means a complete reevaluation of our view of nature and is equivalent to the discoveries of Copernicus and Kepler and Newton. So, as I started to dig into this, it was fascinating seeing who was promoting Einstein and what their reasons were. The New York Times worked very hard to be a paper of record and be impartial, but it had Jewish ownership, and occasionally Adolf Ochs, who was the editor and publisher, he would push Jewish causes very heavily. The New York Times did a lot of publicity on the Leo Frank case, which was just a few years before this, and really heavily pushed Einstein, which we'll see further when we talk about Einstein's visit to the U.S. in 1921.
And for people, sorry to interrupt, but for people who don't know, the eclipse of 1919 supposedly proved that mass influenced light, right? That was basically the core of it.
Yes, right, and that Einstein's theory of curved space, it was taken to validate Einstein's theory of curved space. And I think part of the reason relativity became so popular is these scientific ideas were labeled as relativity and were taken popularly to mean, well, there are no absolutes anymore. All truth is relative. And I think that's a large part of socially why it got the play and interpretation that it did.
Interesting. Okay. Yeah. So Einstein, the New York Times, maybe pro-Jewish.
Well, the fascinating thing is when you look at the Times of London, because, then as now, of course, they don't even say of London. You're supposed to know, when you say the Times by itself, that's the one they mean. But then as now, it was the paper of record for the British Empire. And you could kind of understand how they would be, they were interested in reconciliation after the war and in promoting internationalism. Einstein had been a good German, one who was a pacifist, who disapproved of the war. And so it was kind of a way of contributing to the internationalization of science. It was fascinating to me just a few months after they were busy promoting Einstein very heavily. That's when the Times published the Protocols of Zion, at least initially when they were regarding them as being the legitimate publication. Then they published a debunking of them a year or so after that. But they were very involved in the promotion of Einstein, and it kind of goes back to some interesting speculations I've seen from Richard Poe. Recently wrote a book about how the British invented communism, and he argued that they were responsible for, bifurcating Judaism into the Bolshevik branch and supporting it in Russia, and into the Zionist branch. Some interesting speculations that may be involved in the promotion of Einstein, but that takes us a little far afield here.
Gotcha.
So as you continue looking at some of the over-the-top headlines about the learned being confounded. One of the popular spokespersons for physics of the day was Oliver Lodge. He had done some of the pioneering work on radio and in developing Maxwell's equations. And ironically, at the meeting where where the general relativity results were first published, everyone was expecting him to speak, and he rose and left because he said he had another engagement and offered half-hearted refutations. It was peculiar seeing how limply one of the champions of the ether theory just folded in the face of these results. So one of the things I think isn't widely appreciated is how even physicists regarded relativity and one's appreciation of it as being almost an aesthetic issue. J. Robert Oppenheimer said that Einstein's work was widely understood and applied in the physics community, but there were always those who didn't like it, as there are those who might not like the painting of Cézanne or the quartets of Beethoven. Max Born said that the foundation of general relativity appeared to me then, and still does, as the greatest feat of human thinking about nature, the most amazing combination of philosophic penetration, physical intuition, and mathematical skill. But, he acknowledged, its connection with experience is slender. It appeared to me like a great work of art to be admired and enjoyed at a distance. Ernst Rutherford, who was one of the pioneers of nuclear physics and something of a relativity skeptic, said, he made the offhanded compliment that the theory of relativity, quite apart from its validity, cannot but be regarded as a magnificent work of art. So the fundamental concept here is, physicists, even if they used the Lorentz transforms and some of the principles that arose from relativity, did not necessarily appreciate the aesthetics of relativity. And that really gets back to the whole top-down versus bottom-up approach to science, whether it should be deductive from basic principles like Einstein did, or inductive, looking at electromagnetic phenomenon and deriving the appropriate transforms and conclusions from that. And the unprecedented publicity campaign really antagonized a lot of Einstein's contemporaries, and Einstein really threw fuel on the fire. He had a number of critics. Probably the single most prominent was a Nobel laureate named Philip Leonard, who took issue with relativity. Leonard and another optical physicist, Ernst Gerke, they both challenged Einstein's priority. They pointed out people had come up with the formula for light bending around the sun before he did, that Poincaré had largely developed the theory in advance of Einstein. And Einstein's response to this was to write a dialogue that looks suspiciously like a takeoff of Galileo's system of the two worlds. And it was a dialogue between a critic and a relativist with a touch of condescension toward the simplistic arguments that the critic was unable to understand. And that was about as endearing to Einstein's critics as Galileo's version of the same kind of approach was to the Pope at the time. So it was not a good way to win friends and influence people by implying that they were stupid and slow for not being able to understand you.
Gotcha.
So one of the really fascinating things is in 1920, a physicist named Paul, well, not even a physicist. No one really knows what his background was. He claimed to be an engineer. There's no record that he was ever an engineer. He seems to be a kind of grifter and con artist named Paul Wayland, claimed to be the head of what he called a working group of German scientists for the preservation of pure science. And he wrote a very inflammatory letter in August of 1920, claiming that relativity was scientific hypnosis and a big hoax, and it was all plagiarized. And a few weeks later, he rented the Berlin Philharmonic Hall, which is like one of the premier event spaces, huge capacity, and hosted a public presentation on relativity. He gave a very inflammatory talk. Gerke also made a presentation that was a lot more academic and matter of fact. Einstein attended and laughed and claimed he found it very amusing, but he was obviously very disturbed by it, because he then threatened to leave Berlin, and he wrote what even his friends regarded as an angry and vicious polemic, and chose Leonard to blame for the presentation, even though Leonard was not there and was not involved. Some of Leonard's writings were distributed, but he had not been involved in it. And then Leonard took personal offense at Einstein's comments. That was really the start of the feud that they had. There was a meeting a few weeks later that I'll pick up a bit later. But it's kind of important to understand the attitude toward publicity at the time. Einstein was getting all of this intense publicity on the cover of magazines, articles lauding him as the greatest thinker ever, and above Newton and Kepler and Galileo and so forth. This was at a time when his friend Max Born wrote a book on relativity, and he thought, let me put a photo of Einstein in the book. And their mutual friend Max von Laue was just utterly scandalized at this act of promotion. It was, it was too far for a popular book, let alone what purported to be a professional text in relativity, to have this dramatic glamour shot of Einstein on it, and Born promptly deleted the figure from the future editions so as not to engage in that shameless promotion. It's fascinating looking at all of the early 1920s promotion of Einstein, because we today are so jaded and skeptical and capable of exercising a lot more discernment on the propaganda that is coming down the pike and being thrown at us. Not that we're always capable of resisting it, but it's fascinating to look at the 1920s, when all these techniques were new, and how comparatively crude and heavy-handed they were, because you can really see the propaganda machine in action when you look at these things. Now, this is one of the most fascinating aspects of the promotion of Einstein, this mysterious gentleman named Alexander Moskowski. He described himself as being an adherent of the cult of Einstein. He was an author of a number of books and novels. He wrote books on jokes. He wrote books on the occult and on science fiction. Of course, when I heard he was an occult author, that immediately perked up my antennas, and I looked into that a bit, and I'll talk more about what I found in the dead ends I reached. But he had a lot of long conversations with Einstein, and collaborated with Einstein on a very fawning biography of Einstein. It scandalized Einstein's friends. They urged Einstein to stop the publication. He made a half-hearted effort, but most of the biographers who've discussed this agree that he kind of let it happen, and it was over the top. There are some phrases in it that are just very much exaggerated, and caused a lot of problems and caused a lot of offense. One of Einstein's contemporaries, the mathematician Felix Klein, said, in his personal utterances, Einstein is always so charming, quite unlike the foolish publicity circus set in motion for him. And when I looked into Moskowski, of course, when I see someone has written books on the occult, my initial reaction is, okay, what occult group was the guy involved with? Near as I can tell, he was involved with a group called Gesellschaft der Freunde, which was, near as I can tell, just a fraternal self-help professional organization of Jewish businessmen, mostly in Berlin. But when you take a look at some of this early history of Einstein, it's said that Poincaré attributed the discovery of relativity to Einstein, and Moskowski said so. But it wasn't mentioned at all in Poincaré's 1908 books. We have this account from Moskowski that he went and he heard this talk by Poincaré on relativity. And even though Poincaré had not really mentioned or given credit to Einstein in his book just a couple years earlier, according to Muskowski, he had spoken of Einstein in such terms that Muskowski became obsessed with understanding Einstein and the importance of his ideas. He reported that Poincaré was filled with misgivings and obviously very stressed about the potential of Einstein's revolutionary approach to threaten science as currently understood, but we only have his word for it. He reported that Poincaré had lauded how wonderful Einstein's creativity was in a letter of recommendation, which normally you would think those kinds of letters are kept private, but Muskowski got a hold of it somehow without disclosing how he got it, and reprinted the letter without any details of who it was to or how he got it. And he was the author of one of the most over-the-top articles, the one that appeared behind that cover photo of Einstein, and wrote that biography that all of Einstein's friends were concerned and appalled about how flattering and sympathetic it was. And with Poincaré dead in 1911, it would be very hard to challenge what he had to say. So he very clearly was working extremely hard to promote Einstein and develop this legend behind him, but I haven't been able to come up with any ties further. So if you or any of the audience have any ideas of whether he might have been involved in a broader effort to promote Einstein in particular, it'd be interesting to run that down, but I've pretty much reached a dead end on that.
Gotcha. Okay. Well, that's a message out to the audience, guys. Keep an eye out. Muskowski.
A little bit of background. In 1917, the British issued the Balfour Declaration, basically expressing their approval and support of Jewish colonization in Palestine, which was a bit presumptuous of them because it was still under Ottoman control at the time. But after the war and after the Ottoman Empire was defeated, they were able to take possession. And in 1918, Chaim Weizmann founded the Hebrew University in Jerusalem. He's a fascinating character. He did a lot of very important chemical work for the British. He came up with an organic process for generating acetone, which was kind of new in chemical engineering at the time, and that being a very critical war chemical. So there's some thought that some of the British support, in addition to the Rothschild angle, that some of it might have been paying back the favor of Weizmann for his contributions. Well, in 1919, a German Zionist named Kurt Blumenfeld, recruited Einstein and got Einstein interested in Zionism. In 1920, Einstein was trying to raise money. This was before he got his Nobel Prize winnings. Supporting the ex-wife and kids in expensive Zurich was kind of tough. The hyperinflation was just starting to, it hadn't really hit full blast, but it was in process. He didn't have a lot of money. He solicited a bunch of American universities asking for $15,000 per lecture, got rebuffed, and decided to go to Belgium, to Leiden, and attend the Solvay conference instead. Well, Blumenthal persuaded Einstein to join Weizmann on a fundraising tour to the U.S. A lot of Einstein's colleagues were very upset. Fritz Haber, who I'll talk more about later, fascinating character. He was an assimilated Jew. He'd converted to Christianity. He regarded it as akin to fraternization with the enemy, hanging out with the British and the Americans. Walter Nernst was upset because he was one of the co-founders of the Solvay conference, but amid the post-World War I tensions, the Belgians were not inclined to invite any Germans to the conference, except for Einstein, because of his international reputation. And he was angry that Einstein backed out and that Germany would be unrepresented. Einstein declared that he was annoyed by the undignified assimilationist cravings and strivings which he has observed in so many of his Jewish friends. So when Einstein came to America with the Zionist Party, over 5,000 people were there at the docks to greet the party. And it turns out they were there to greet the Zionists, that the Eastern European and Russian Jews in New York had, their newspapers had promoted the Zionist mission. It was very popular with that element of the Jewish culture at the time, and that was what motivated this turnout. Well, the non-Jewish reporters who were present saw this huge crowd, and they were asking, who they were there for. And, people were talking about Weitzman, but they'd never heard of Weitzman, but they had heard of this Einstein guy. So it got misinterpreted as people there to celebrate the scientific achievements of Albert Einstein. So kind of a case of mistaken identity. Now, there was another dynamic at play that was kind of fascinating. The more establishment assimilated American Jews, the ones running the New York Times or controlling the media, were very skeptical of the Zionist program. There was a bit of a rift between the longtime establishment Jewish community and the newcomer Russian Eastern European Jewish community. The newcomers were in favor of the Zionist cause. The more established assimilationist American Jews were willing to charitably support their brethren in Palestine, but they weren't interested in promoting the concept of an independent Zionist state in Palestine. So that tension played out in the trip, and is part of why Einstein got promoted. He was promoted to distract from the Zionist mission. Walter Isaacson, who wrote a biography of Einstein, declared that Einstein's trip to America triggered the kind of mass hysteria that would greet the Beatles 4 decades later. And that, of course, got me thinking about some of the speculations about the Beatles and their popularity and how that might have been engineered. And when I started digging into the question of whether there was some engineering involved in the mass and unprecedented publicity Einstein got when he arrived in America, I landed at a gentleman named Edward Bernays, who's known as the father of propaganda and public relations. He started off his career as a theatrical publicist on Broadway. His first big triumph was in 1913. He promoted a book called, or a play called Damaged Goods, about a man with syphilis who has a child and passes on the syphilis to the child. Of course, talking about sexually transmitted diseases in Broadway plays was beyond the pale at the time, and no one would support the play. He generated or created an organization to promote it as an educational exercise, and he got support from Rockefellers and Vanderbilts, and even a young Franklin Delano Roosevelt signed on backing this, and ultimately got the play produced. That really that starting point in his career kind of illustrates not only his effectiveness at promoting his clients, but how he often mixed his political activism as kind of a side interest with his publicity projects that he took on. When World War I broke out, he started in on the U.S. Committee on Public Information. That was the American War Propaganda Group. And he declared that the war opened the eyes of the intelligent few to the possibilities of regimenting the public mind. And that is what he set out to do by founding one of the first public relations consulting groups in America. Unlike a conventional public relations expert who would take a reporter out to lunch and try to wheedle and cajole them into printing a press release or talking with an editor about, hey, why don't you promote my client for these reasons? His approach was to create events and circumstances which newspapers are compelled to notice as news. Some of those examples include when he got married. He wanted to promote his wedding. And instead of just submitting a wedding announcement to the New York Times, he got his wife to go to the Waldorf Astoria and register for the honeymoon suite under her maiden name, which ended up causing a lot of pearl clutching and publicity. Over 200 newspapers reported the scandal, and the August Hotel ended up allowing that to happen. And what have we come to, and so on and so forth. The Waldorf Astoria was one of his clients, and he ended up promoting the cause of feminism. He was an early supporter of women's rights and feminism. So that was another politically charged twofer to his credit. He started the art of celebrity endorsement. He got Calvin Coolidge elected, in part because he got a bunch of Broadway actors to come to the White House for a pancake breakfast. He was instrumental in getting women smoking. He got a bunch of women to smoke cigarettes up and down New York's Fifth Avenue on Easter Sunday, which got a lot of press. And then when the owner of Lucky Strikes complained women still weren't smoking enough because they didn't like the packaging, Bernays said, well, that's easy. Change the color of your packaging. And the owner of Lucky Strike said, no, we spent a lot on this packaging. You change the colors that women like. So Bernays went off and did that. He got Parrish fashion designers to adopt green as the color of the season, even held a green ball to promote the color of green. A bacon manufacturer hired him to promote bacon, and he came up with the idea of setting up a medical educational group where doctors promoted the idea of a hearty breakfast. So the American eggs and bacon breakfast, that's Bernays' handiwork, still in operation a century later, promoting sales of bacon.
Yeah, bacon was the throwaway item. That used to be the unwanted piece. So they elevated it into something that's now ubiquitous. Yeah,
absolutely. Now, the thing that was fascinating is in his memoirs, he notes how he was a friend of Chaim Weizmann. And so much of a friend that he claims Weizmann offered him the position of foreign minister for the new Zionist state in Palestine when it would be founded. And when you look into the records, there are contemporary records that say he consulted with Weizmann, but there's no record I was able to find on what he consulted about with Weizmann. So my speculation is he may well have been involved in the publicity tour. Whether he was or not, it was clearly an example of the kind of events and circumstances publicity that was his hallmark. And he also commented, the conscious and intelligent manipulation of the organized habits and opinions of the masses is an important element in democratic society. Those who manipulate this unseen mechanism constitute the ruling power of the country. So very, very prescient. He's well worth studying, and his book Propaganda is a very short and easy read. I recommend it. So I want to go ahead and kind of speed up a bit on the publicity that was.
We are at, just a sec, Hans, we are at the 1 hour mark. You're on slide 26. You have 65 slides. Do you want to break this into two, or do you want to just hurry up and make it through in a half an hour? What do you? I'll leave the choice up to you.
We'll probably have to break it up.
Okay, let's do that. Let's just plan to meet sometime early in June. So this will be part one. Where can people find kind of to catch up with your stuff? I know website, Substack. Can you mention those?
Yeah, my Substack website at etherzar.substack.com. My Fields and Energy Substack. This is basically a summary of a number of posts I've done over the last 6 months or so.
Gotcha. So these, you can kind of see all of the articles here. You can see this. Fields and Energy. A lot of articles, a lot of different postings. And can you talk about what's the Society for Post-Quantum Research? Can you talk about that?
That is a group that I set up to kind of provide a commercial basis for my my work. The slide or the post that you're sharing right now, I mentored a high school student to do quantum entanglement for his high school science project. What he did was take a radioactive substance, sodium-22, that emits positrons, basically antimatter versions of electrons, and they immediately annihilate and they create an entangled pair of gamma rays. And he was able to set up a pair of Geiger tubes to measure those and to count the number of coincidences and demonstrate that there was a statistically improbable number of coincidences that demonstrated that quantum entanglement was happening in the system. So it's really a very cool little experiment he was able to pull together, because normally the laboratory equipment to do any sort of experiment with quantum entanglement is at least $30,000 to $50,000 if you wanted to look at single photon measurements. But if those photons are gamma ray photons, then you can use a Geiger counter tube. It's not all that sensitive, but you're able to do enough. You'll get enough data to get a meaningful result off of it. It's based on, or was inspired by a Scientific American article by, it's listed there. I think it was George Musser in
Right. Yeah,
a few years ago. And he's the author of that book, Spooky Action at a Distance, which I would recommend. It's a good book if you want to understand how quantum entanglement works from a layman's perspective. But he described this experiment, and we, unfortunately, the equipment that he used is no longer available. So we had to cobble together a set of equipment that Corbin was able to put together for his science project.
Gotcha. So that's it. So you've got a Substack, you have your website, which is SPQR, right? That's the Society for Post-Quantum Research. Why is it post-quantum? I don't understand that.
Well, because I think we're going to be moving into a new realm of quantum physics. That term has been used before to denote, the possibilities of quantum computing. It's thought that if we had a quantum computer, it would be able to solve all sorts of previously intractable problems like factorization of prime numbers, which is one of the key ideas behind cryptography. I'm kind of skeptical about quantum computing, particularly when you consider that the biggest number that has been successfully factorized using quantum computing is 15. So I think there's a long way to go there. I'm a little skeptical about some of the premises underlying quantum computing, but I think that the fields and energy approach to electromagnetism and quantum mechanics could allow us to leapfrog some of those limitations. And that's why I set up the Society for Post-Quantum Research, and kind of hearkening back to a more classical motif in physics.
Gotcha. And Johnny Sumatra mentions Neil deGrasse Tyson is one of these kind of science experts that's promoted. It's interesting. So Einstein could be in the veil that there's another guy, the science guy or whatever. Like he was an actor before he became the science guy. Then he got promoted, and he has some interesting political opinions. I forgot his name. Bill Nye, the science guy. That's right.
Yes.
So,
and that's another feature. The people who get promoted and get publicity are the ones who are on message with what the people who control that media want you to hear. So
right.
It's very tough to get independent views, and I think podcasts like yours are an important element of letting people hear independent perspectives on things.
I agree with you. That's kind of why I do what I do. But Hans, thanks so much for your time. I tried to keep up with you. Really interesting. I didn't know a lot of that history about Einstein, and they never talk about him in the context of other physics luminaries. It's just him, which I think is interesting in itself.
Well, he's kind of a physics icon, but it's a mythology that has been built up around him. And it's very telling that when there was an existential threat and America was busy working on the Manhattan Project, Einstein was not invited to participate. And that really kind of shows you the attitude that the physics community had of Einstein even then, that they were quite content for him to stay puttering and theorizing at Princeton instead of being involved. Uh, there's the conventional wisdom is he had this brilliant youth where he came up with relativity, and probably the last significant thing he did was the Bose-Einstein statistics, and he just couldn't keep up with the creative new ideas in quantum mechanics. And even his EPR paper, well, that was just the last cry of the angry old man arguing that the Copenhagen interpretationists needed to get off his lawn. He really wasn't taken seriously. And my perspective is that I'll get into the next time, is that he came to realize that his approach to relativity, focusing on observables, was wrong, and that the causal connectedness of reality was very important. That God didn't play dice with the universe. And it's important. A lot of people's conceptions of quantum mechanics, they'll focus on things like Schrodinger's cat being both alive and dead until you open the box and look in, or this concept of spooky action at a distance. And both of those concepts were, reductio ad absurdums that were invented by Schrodinger and Einstein, respectively, to show how ludicrous the conventional interpretation was. So we'll get to that here in part 2.
Cool. And Johnny writes, amazing broadcast, gents. Sub to Hans at Substack now. Johnny, thanks for listening. He's listening on X, so you can see these live on X too. I'm now streaming there, or Rumble. And also, I will put a link to Hans's Substack, so people check that out. Fields and Energy. And then also our earlier conversation we had last month in April about the Whys of Heart, a modern-day reimagining of the Scopes Monkey trial. Check that out, too. I'll put a link in the show notes for this, and then I'll start put something together for June, and we can go back and do the rest of these slides. So it's Hans G. Schantz, Schantz, and the title for the talk today was Einstein, Relativity, and Modern Physics. Thanks so much for your time.
Sure. Thank you for having me on.
All right, cool. Stay there. All right, I just have to